still continuing trigonometry. We're going to look at our last two examples, but all the way through. So example 7. At 5 p.m., a vertical post 10 meters high. A vertical post looks like that, 10 meters high, so 10 meters. Cast a shadow 6 meters long. So where does the shadow usually fall? On the ground, right? That is 6 meters long. To the nearest degree, what is the angle of elevation of the sun? So elevation, elevate, to go up, to rise. So obviously the sun's going to be up there somewhere. So what is the angle of elevation? So from the horizontal, rising. What is that angle? All right, so turn to the next page to identify the sides and copy the triangle. So this will be step 2. So you've copied the triangle down. You draw your man. He P's on what? H. Then O is across from the angle, and then A is what's left over next to the angle. Turn to the next page to set up the equation. So we're going to write SOHCAHTOA like we did before. And then we need to box what we need, which is O and A, because those are the ones we have numbers. So that's tan. Write it out. So tan of theta equals opposite over adjacent. Go get the figures. So tan of X, because I don't know what it is opposite, which is 10, over adjacent, which is 6. Turn 2 pages over to solve for the variables. So we're just doing an example all the way through. So you write it out again. So I had tan X is 10 over 6. And then what are we going to do? We're going to take the inverse tan to get the angle by itself. So you stick that in the calculator. So second tan and then 10 over 6. And then what did the question tell me to do? Round to the nearest degree. So 59.0, so that doesn't do anything to it. So 59 degrees. Example 8, airplane flying at an altitude of 3,000 feet. So here's my plane. It's flying at an altitude of 3,000 feet. So what's that? Vertical height. Remember, that's the height from the doctor, right? 3,000. The angle of depression, I'm feeling low. So the one going down of the airport ground signal. So I need an airport. So that's somewhere on the ground. So let's call that the airport. So the angle of depression. So it needs to be going down. So look at the plane, draw a horizontal line, and then make it go down. So now what we're going to do is just redraw this triangle that we have, because that's the angle of depression. So it's not inside my triangle, and I need to make it inside the nearest foot. What's the distance between the airplane and the airport? So the airplane to the airport is X. So I'm going to redraw this triangle so that my 29 degrees is inside. So there's my 29. Then the height is still going to be the 3,000, and X is the diagonal. So now my 29 is inside my triangle. Turn to the next page to identify inside and copy the triangle down. Okay, then we're going to run through labeling. So here's my man with his legs. There's his package. He pees on H. And then across from the angle, across the road, that's going to be opposite. And whatever is left over is adjacent. Then go ahead and color in, or box actually, what has variables and numbers on the outside. So it's O and H. Turn to the next page so we can set up the equation. So we're going to write out SOHCAHTOA, and then what did we use? We used O and H. So O and H is sine. So we're going to set that up. So we're going to have sine of the angle is opposite over hypotenuse. So sine of, and what's the angle? 29 is opposite, which is 3,000, over hypotenuse, which is X. Then turn 2 pages so we can solve it. So we're almost there. We're in the last step now. So copy it down. So sine of 29 is equal to 3,000 over X. So we're going to put a 1 underneath it. Cross multiply, divide. So it's going to be X sine 29 equals 3,000. Then divide both sides by sine 29. Punch that into the calculator. So X equals, make sure you're in degrees, 3,000 divided by sine 29. And I believe you're rounded to the nearest foot. So that 9 is going to make that 7 go up 1. So 6,188 feet. And that's it. So if you follow this step by step, you'll be able to solve trigonometry problems. Let's practice.